Okay, let's just get started with a new series. And this is going to be generics in Java. Okay, my mic is here. I hope you can hear me well. I'm recording, by the way, after a long time. Okay, so generics in Java. So how can we approach this topic? So what I'm thinking that we're going to be having a question and answer session. Okay, and we're going to be keep on having few of them. So accordingly, we can get prepared for the interview specific questions, and also we can start learning the topic in a better manner, right? So we're going to be keep asking questions and we'll try to figure out the answer for that. Okay, so that's going to be the motto of this series. So in this video, let's just try to ask ourselves one simple question, and that is going to be, why do we need generics? What is the need of that? And how can we create generic classes? Okay, let's just get into that and let's try and understand why is actually Java needs generics. What do we mean by generics? Okay, and why it is important. Let's just get into it. All right, so first of all, I have a project here called generics1. Okay, this makes sense. I have a src folder. Let me go ahead and create a class. So the class name is going to be aquarium. Okay, and I want to put this aquarium class inside a package called generics.demo. So what the heck is this aquarium that I'm trying to create over here? So, aquarium, right? Where different fish can live. We can create a kind of man-made environment where we can put different fish inside a glass container or something. So let's say I'm planning to build an aquarium here. Maybe I'm creating a game or something where I want to instantiate an aquarium. So something like that. So inside this aquarium class, I want to obviously put some fish. So I'm going to say fish 1 and fish 2. Okay, let's say I want to put a couple of fish here. Okay, so the variable fish that I'm defining over here, what is going to be the type of it? Good question, isn't it? So what kind of fish you want to put inside this aquarium? Is it going to be a goldfish? Is it going to be a starfish? Is it going to be a fighter fish? Is it going to be a shark? What do you want to put inside this aquarium, right? You need to define the type of this variable, right? So you can be very specific, by the way, over here. For an example, if you might have different types of fish. When I say type, imagine type as a class. When I say type means it's a class. For example, I'm going to create one type of fish. Let's say this is going to be a goldfish. Okay, imagine goldfish is a class and I want to put a goldfish inside this aquarium. So I'm going to say goldfish. Okay, I'm going to import the class here, goldfish, and this is going to be the type of the fish, right? Over here also I'm going to define the type. But if I want to do so, this aquarium is going to only contain the fish which is of type goldfish. Okay, now what if I want to instantiate this aquarium here? For an example, to instantiate the aquarium, I'll give a constructor. Let me expand this. I'll go to the source and I'm going to say generate constructor using fields. Okay, click on this. So let's say I have a couple of fish here. Okay, and that's what I'm initiating those fish value over here by getting it through a constructor, and I'll be assigning to this variables. Now my question is, let's say if you have an app class, let's say I'm going to create a class. The class name is app, and let's say inside this app I want to instantiate the aquarium. So I'm going to say aquarium, and aquarium is equal to new aquarium. Is going to ask for a couple of fish here, and I have to create couple of goldfish, right? I'm going to say goldfish here. I'm going to instantiate the goldfish, and assigning it to the first variable. And the second fish that I want to put inside this aquarium is also a goldfish, right? Now, what about I have another kind of fish here. Let's say I'm going to create another class, and this is going to be a starfish, okay, for an example. And I want to put the starfish also inside this aquarium. So if I'm going to go to this app.java here, and I'm going to instantiate a new aquarium class here, like this. I'm going to say another aquarium I'm creating, but here I'm going to put some starfish, okay? Now this is not possible, right? Why? Because the type that I have defined inside this aquarium, this constructor, you can see the type is goldfish. And this constructor I'm creating to instantiate this variable, to accept this variables, the data for this variable, and I'm assigning it to this. And here is the type of my fish, which is a goldfish. I want to put a starfish here. I want to put a, let's say fighter fish here. This fish type can be anything. And if that is the case, then I have to make sure this variable, it can accept any type of fish. So what I'll do, I will take this type as object, this variable types as object, all these variables as object. Now, in Java, every class super type is object. So, like starfish super type is object, goldfish super type is object, any class that will be creating the super type is object in Java. So we can assign any type of fish over here right now. So right now, what I'm going to do, I'm going to initiate a different constructor here. So source generate constructor using field, generate, which is good. Now I'm creating another aquarium, remove the super, accepting an object right now. So if we're going to go to my app.java, see, now I'm getting no error over here. I can create a goldfish and put it inside the aquarium. I can create a starfish and can put it inside the aquarium, which is good, which is a good thing, right? And now if I want to, let's say, let me comment this out, okay? And let me just get it over here. Now, what if the fish that I'm putting inside the aquarium, I want to get an access for that, right? Let's say I'm going to say aquarium and I want to get the fish, okay? I should not be able to access the variable directly. So what I can do, I can go to the aquarium and I can make all this variable as private. And this is also going to be private, all right? So a couple of private variables. If I'll go to my app.java, if I'm going to do control space right now with this aquarium object that I'm creating, let's say with this aquarium, I want to access the fish this aquarium contains, I need to have the getter method. Now I have no direct access to the private variables, so I need to create some getters here. So I'll go to the aquarium, and to access this fish that I'm putting inside this aquarium, I will give some accessors. So I'll go to source, and I'll create some getters. So select getters, do generate, which is good. Now I can have access to this fish one. It will return an object. I'll also have access to this. It will also return an object. So I'll go to app.java. I can just do aquarium.getFish. Okay, getFish1. Okay, and what is this guy is going to give me? This is going to give me a object, right? So I'm going to say object, and this is going to give me a fish, right? And like that, I can also copy this line, put it over here. I'm going to say fish2. Let's say this is the fish1, this is the fish2, and I want to print them. So I'm going to say sysout, and I'm going to say fish1 plus, and I'm going to say fish2. So I'm going to say fish2 over here, okay, which is good. Now, if I'm going to run this, I'm going to get the access to the couple of fish that I'm putting over here. You can see these are two goldfish object that I'm getting over here and printing it over here. But whenever I'm doing a get fish with this aquarium object, I'm getting an object back, okay? But I don't need to have the access to the object. I want what is the exact fish which is living inside this aquarium, which is a goldfish. I know that. So how can I get the goldfish out of this aquarium whenever I say get fish one? Obviously, I need to cast it. So you might say, why do you want to get the goldfish over here? For an example, inside this goldfish class, there is a method here. Let's say public void swim, okay, or something. Okay, and I'm gonna say this out. Let's say the fish is swimming. Okay, so let's say I have this. So now if I'm gonna go to my app.java, okay, let's say I want to call this method. Let's say fish1 dot swim. I cannot have access to the swim method over here because the fish1 is an object type. And inside this object class, I don't have any swim method. I do have the swim method where I do have the swim method inside the goldfish class. So I need to have access to the goldfish object if I want to invoke this method. So inside my app.java, what I have to do, whenever I'm going to do get fish1 over here, which is going to be this object, I know this aquarium contains a couple of goldfish. So in order to have access to that, I need to cast this object. I'm going to say the compiler, hey compiler, whenever you're going to do get fish, obviously if I'm going to hover on this is going to give me an object back. So whenever you're going to see the return type, this is an object. But over here in my app.java, whenever I'm going to say get fish1 with this aquarium object, I'm going to tell the compiler, okay, let me remove this. Okay, I'm going to tell the compiler that, okay, I know whenever you're going to do this, you're going to be returning me an object, but I'm sure inside this aquarium, the fish1 variable, which is the first parameter over here, is going to contain a goldfish. So I know that the type this aquarium fish1 is holding is a goldfish. I'm putting a goldfish over here. I'm sure about it. So I'm going to tell the compiler that, okay, whenever you do this, you blindly cast it to goldfish. So I'm going to say goldfish, okay? And now I can safely assign this to a goldfish object instead of a object, okay? So I'm going to say goldfish fish1, okay? So, which is good. Now I can happily take this fish1 over here, okay? And I can put it over here, and I'm going to say fish1 dot swim. And you can see I have this method. So I can just do fish1 dot swim, okay? Like that, the fish2 is also a goldfish, right? So you can happily cast it to goldfish because you are sure the type of the second fish that the aquarium contain is a goldfish. So you can cast it to this. You are telling to the compiler that, okay, I'm sure the fish that you'll be getting over here is a goldfish. So cast that object to goldfish. And also I'm going to assign this to a goldfish. So I'm going to say goldfish, okay, and fish2. And I'm going to say swim, fish1 dot swim. And also with the fish2, this is also a goldfish. I'm going to say fish2 dot swim, which is good, right? Now, if I'm going to do run this, okay, you can see both the fish are swimming, and also I'm printing the objects of the fish, which is pretty cool, okay? So this is one of the happy scenario over here. So now I want to show you this scenario. Imagine you have a little brother, okay? So what he basically does, let's say you have written this program, imagine this is a simple game, and right now you have instantiated the aquarium, you did put some goldfish, and both the fish are swimming and all working good. It's a happy past scenario. Now imagine you have a little brother. What he does, he came over here. Imagine he created a fish here called shark, okay? I'm going to say shark. Imagine he did create this class called shark. This is another fish, obviously. It's a dangerous fish for sure, but it's a fish, right? So now I'll go to my app.java class, okay? So here I'll just get rid of the swim method. I don't need that. This is just to show you that, the getFish method that you are calling, you can actually cast it to the actual type of the fish if you want to invoke any method on top of it. So instead of making it an object, you can also cast it to the actual fish type. The problem with this approach is whenever you are actually creating an aquarium object, you are putting some fish inside this, but whenever you are doing get fish, it is returning you an object. It is not returning you the exact type of the fish. So you have to cast it by yourself, and you need to have a hold to that. Okay, so that's the problem. But yeah, we'll bear with it. Okay, so not a problem, because we made our aquarium class generic because we can put different types of fish. If you are not putting object over here as a type, then you won't be able to put different type of fish inside this variable. Okay, so that's why to make it generic, we have used this class here. This makes sense. Now inside my app.java, as I said, my little brother has created a different fish here, and this is shark. It's a dangerous fish. And what that guy did in your app.java, he came over here and he basically changed the second fish to a shark, something like this. All right. Now, there is no problem. The compiler is not complaining. The compiler is not complaining like, hey, this is not a good pair that you are creating, because how can you create an aquarium where you can have two different fish type? Like one fish is goldfish, one fish is shark. The shark will eat the goldfish, right? But, the compiler didn't complain. My Java says this is okay. This is good. So the aquarium instantiation is fine right now. And look at the first line, okay? I'm getting the fish, and I'm telling the compiler that, hey, compiler, the first fish type that you'll get is goldfish. Whatever you get over here, you cast it to goldfish and assign it to a goldfish object, okay? The same I said to the compiler, the fish 2 that you will be getting over here is also a goldfish, okay? You cast it to this, and you assign it to another goldfish object. Whenever I'm going to do this, I'm telling the compiler, I'm forcing the compiler that, okay, whenever you're going to be running this code, be assured in the runtime, whenever you're going to do this, you're going to be getting a goldfish from the second fish type. But actually, this is a problematic situation right now. My little brother has changed the code over here. This is my previous code, right? The compiler is not complaining. Compiler is saying, okay, I trust you, developer. You said, I'm going to be running this code, and I'm going to be casting it to goldfish, and I'm going to be assigning it to this. Okay, but let me run this. Now this is actually a problem. You can see right now I'm getting a class cast exception, okay, because of the line number 9, which is this. And here in the runtime, we're having an issue. Why? Because this aquarium right now has a second fish type, which is a shark. Okay, so we have just changed this one, and whenever we are casting it in the runtime, we're getting the class cast exception. So with this kind of coding approach, we need to be very sure whenever I'm writing the getter method, I'm calling the getter method, what kind of fish that I'll be getting. Okay, here this is an unexpected combo that I'm creating. Okay, I should not be able to, first of all, I should not be able to instantiate this aquarium in this way. I need to make sure the fish type should be same. Okay, if it is goldfish here, the second type also should be goldfish, so that they both can live happily. So this is a weird combo I'm creating, which should not be done in the first place. And if I'll be doing so, I need to be very sure whenever I'm trying to use the get method, it's going to give me an object. So I need to make sure with what type I'm casting, because the casting will be done in the runtime. So this code will be invoked in the runtime. Imagine this code, I'm pushing it to the production, and here while compiling, see, this is this exception that I got whenever I ran the code. But now the compiler is not complaining, right? The compiler says, okay, the code looks fine to me, right? So the cast will happen in the runtime. Imagine it is running in the production, and when the production only, you are getting an exception like the class cast exception, your entire application is breaking. I cannot able to cast a shark to a goldfish. So this is the exception, the class cast exception. The shark cannot be cast to a goldfish, okay? So the conversion failed. So this is gonna get you a shark, but I'm saying goldfish over here. So I need to make sure this should be a shark. Okay, something like this. Now it should be okay. If I'm going to run this, it should work fine. But look at this situation, which is my previous situation. Okay. First of all, the problem arises because the compiler didn't complain whenever I did instantiate this aquarium object. So how can we stop this problem? How can we get a solution for this problem? How can we force our compiler to stop the developer to create this kind of weird combo? And there comes generics. Okay, so the runtime error in this scenario, I'm getting a runtime exception, which is a class cast exception. So runtime exceptions are bad. We need to suppress this to compile time. So whenever we're writing the code, the compiler will warn us this is a bad code that you're writing, which will be problematic in the future. So to do that, we can go for generics. Generics in Java basically came for that. So if I'll go to the aquarium class right now, so to make this code generic, just to make sure like different types of fish I can put inside this aquarium, and I don't have to create different aquarium classes to put different types of fish, I just made it object. So that different type of fish I can put it over here. So instead of doing this, instead of putting object over here, which can be a cause of class cast exception, what I can do, I can use Java generics. And to use Java generics, you can define the type of the class here. Okay, you can basically write a diamond bracket here and you can put anything, okay, any letter. But right now I'm gonna put a letter here called T. Okay, this is a naming convention. I'll tell you more about why actually I did write this T over here. Can I write U over here? Can I write K over here? Can I write blah 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 over here? It's possible. You can see the compiler is not giving me any warning whenever I'm doing this. But I'm gonna write T here. T for type. So I just have a diamond bracket and I did put T. So what does this means? In Java we call now this aquarium type that we have, the aquarium class that we have, this is a generic type right now. Whenever you see something like this in Java, this is basically a generic type. Whenever you see a class does have a diamond bracket and there is something over here, that's a generic type. Okay, that's what people refer generic type. Okay, so if you're gonna see any class like class, some class, and you can see if the class declaration has this diamond bracket and there is something written over here, then some class is referred as a generic type in Java. Okay, first thing. Okay, so why did I put this T over here? And what the heck is this? So now this aquarium is a generic type. It's more general right now. It's more generic right now. So the T stands for type. Type means this is a parameter. This is a parameter. You can think this class does have a parameter right now. This is a parameter for the class. You have heard about the method parameters, right? You can create a method which takes some parameter, maybe an integer parameter or a double parameter, right? And whenever you call this method, you have to pass that type of data, right? If you have a method which takes a int data, then whenever you are calling that method, you have to call that method with int data, right? Like the method accepts parameter, the class can also have parameters, and that we can have using generic. Now this T here is going to be the type. Okay, the generic, right? This T that I'm defining over here, the type means class, I said, right? So in generic, aquarium is a class, and we can, whenever we're instantiating this aquarium class, we can provide the parameter for that class, and that parameter can be defined over here. The parameter can be integer, it can be string, it can be double, it can be goldfish, it can be starfish, it can be Shark, it can be any Java classes or any Java interfaces. Okay, so the generic type that you'll be defining over here, this is what we call a parameterized type. This is the parameter for your class, and this parameter will always accept a class or an interface, not a primitive type or something, right? It's always going to be a class. Okay, so what I mean by that, for an example, right now, whenever you will be instantiating the aquarium, you can already see there is a warning here, because the aquarium is not a normal class right now. It is a generic class which does have a parameter over here. Okay, so whenever we're instantiating this aquarium class right over here, we need to define the type like this. Let's say you have to create an aquarium object. So I'm going to say aquarium. Now the compiler is asking me to define the type. The type, as I said, this is going to be a class, right? So it can be integer. Let's say integer is a Java class, or any custom class like goldfish. This is a custom class. So I'm going to say aquarium is equal to new aquarium. Okay, and forget about this the values that are over here. Now we will not talk about the values. Now I'm assigning null and null, and I'm gonna say goldfish over here. Sorry, I'm gonna say over here, whenever I'm instantiating the aquarium, look at that. This is the normal instantiation. Look, the aquarium class, whenever I'm calling, I'm not defining any generic type. But here, whenever I'm defining the aquarium class and creating an object of it, I'm defining the type over here. And the type over here is goldfish. Like that, here, the type will be, let's say, starfish or something. Okay, so I'm always instantiating this aquarium class with a type. This is the parameter for this class, right? And let's say aquarium 3. And in this object, aquarium object that I'm creating, the type for the aquarium is the goldfish, right? So if you're gonna go to the aquarium class right over here, this T will be replaced by goldfish. This is the parameter that we have passed while instantiating the aquarium object. Like that, if I'm gonna go to the app.java, here I'm creating the aquarium with starfish. So this is the type that I'm providing whenever I'm instantiating the aquarium. So this T will be replaced by starfish. So whenever I'll be instantiating, I will be passing the type for that class. Okay, so remember the terms right over here. So whenever you see a class has been defined with T with parameter, this is what we call the generic type in Java. So if somebody say, hey, that is a generic type, that means it does accept something, and you have to provide maybe the type for that whenever you're instantiating that class. Like aquarium does have a T. If you're going to go to your collection class and see the list or array list, they also comes with this where kind of syntax. That means whenever you're instantiating those objects, you have to provide a type for that. Okay, so now whenever you're instantiating, where you're instantiating this aquarium. So if you're going to go to app.java, now here I'm instantiating this. And you can see now I'm putting goldfish over here. So this is a parameterized type. So when you are instantiating a generic type like this, I can say this is a parameterized type. Okay, this is a parameterized type. Okay, this is a type which does have a parameter. So it's a parameterized type. Okay, so this is one thing. You understand generic type? This is the normal class with the generic symbol over here, the diamond bracket. So this is a generic type. Look at this app.java. Here you are instantiating the generic type, and that time we call this as a parameterized type. Okay, and look at this right now. Now this is basically giving you an warning. The line number 7. This is the previous code that we have written. Here, while instantiating this aquarium, we haven't defined the type over here. Okay, so if we don't define the type over here, this aquarium is a class which accepts some type as a parameter, but we are not defining that. Now this will be called as a raw type. Okay, because this is raw. right? We haven't defined the type over here. We haven't given the diamond bracket. We haven't written a class over here like goldfish or starfish or something. We haven't defined that. So this is a raw type, okay? Forget about this. This is just for our understanding. I'll remove this, okay? Now let's just go back to our aquarium class. So this is T. So this T will be whatever will be given whenever somebody will be instantiating our aquarium class. Let's say whatever the class that the guy is passing, the same I'll be making as the type of the fish 1. Same I'll be making the type of the fish 2. Okay, in the constructor also, I'm gonna define T over here. Okay, and the get fish 1, the fish 1 will return a T over here. So all this object, I'll replace it to T. The get fish 2 will also give me a T back. Okay, so T means type. So if you're instantiating an aquarium with goldfish, then this T will be goldfish. This will be replaced to goldfish. This will be replaced to goldfish. It will be replaced to goldfish. It will be replaced to goldfish. Okay, we'll see that. I'll go to app.java right now. I'm gonna define the aquarium here, and I'm gonna say the type is goldfish. Okay, and here also I'm gonna define the type for this aquarium. I'm gonna say goldfish here, and now look at that. Now if you're gonna go to this aquarium, this T will be goldfish, and once this becomes goldfish, every T over here will be replaced with goldfish. Okay, this all will be goldfish right now. Okay, so now this aquarium is meant for storing the goldfish. Okay, now if you're gonna go to the app.java, the first thing that you will notice right now, this getFish1 method is now returning a goldfish instead of an object, right? So you don't have to cast it again right now to goldfish, okay? So because it is no more returning an object. Right now, it is returning you a goldfish directly, okay? Now, if you're gonna run this program, there won't be any issue, right? So see, you are getting your object printed over here, and you are not needing casting over here right now. Okay, so because the castings are problematic, that can give you exception in runtime, like class cast exception, if they are not handled properly. Okay, now this is a good thing. Okay, so now let's say I'm gonna instantiate the aquarium again. I'm gonna create another object of aquarium, and this time I'm gonna put starfish here. So I'm gonna say starfish, okay, is equal to new aquarium of starfish. And here right now, see, I'm creating this aquarium right now specific to starfish. So this T will be right now replaced to starfish. The variable of fish1 will be starfish. This variable type will be starfish. This T will be replaced to starfish, and this T also will be replaced to starfish, because whenever we're instantiating, we are defining the type for that class right over here. Good, right? So now you can just put new starfish and new starfish. But I'm going to show you an interesting thing right now. Whenever I'm going to do starfish.getFish1, see what it is returning? It is returning starfish right now. Here, what it is returning, the fish one, it is returning the goldfish, because the type here is goldfish. Now, whenever I'm instantiating this aquarium right now, I've defined the type as starfish. So all the getter methods are also going to return the type that you are specifying over here. Isn't that cool? Okay, so I'm gonna go to app.java right now. I'm gonna say get fish1. This is going to get me a starfish. No need of casting. Do a control1, assign the statement to a new local variable. You can see it is returning a starfish. So I'm going to say starfish1, and I'm going to copy this, paste it again over here. Now I'm going to get the fish2. This is also going to be a starfish. I'm going to say starfish2, and I can just write sys out over here to print them. All good. Let me run this. Okay. So you get your object printed for this, which will be goldfish. You get the object printed over here, which is starfish. Now one class, but this is more polymorphic right now. Okay, we don't have to create a different aquarium class right now for let's say fighter fish. If you want to put fighter fish over here, just create a class called fighter fish and instantiate the same aquarium class that you have with by passing fighter fish over here in the parameter. So you are able to write more generic code right now. So you are basically able to reuse this class right now that you have created by passing different types as the parameter. And the benefit over here is that we are right now avoiding the casting here. All right. So if you're going to go to app.java, you can see there is no more need of casting. And this basically protects you with the very dangerous class cast exception. But what if a developer will do some mistake? For an example, let's say I'm a developer and I'm trying to create a weird kind of aquarium. Okay, let's say I'm gonna create an aquarium like this aquarium, and I'm gonna define the type as, let's say, goldfish. Okay, I want to create an aquarium where the goldfish will live. I'm gonna say goldfish aquarium is equal to new aquarium, and here let's say I'm putting some fish here. The first fish I'm putting is a goldfish, new goldfish. Okay, and the second fish that I'm putting over here is a shark, right? New shark over here. If I'm going to do this, the compiler is going to complain right during the initialization. And this is the benefit of generics. This is going to help the developer to force, it is going to force the developer right now to instantiate the aquarium in the right manner. So it is saying, okay, man, you are defining goldfish over here. This is the type of the parameter for the generic. So how come you are able to put a shark over here? This is not valid. Okay. So the error that we're getting in the runtime previously, we can avoid that, because by writing generic code, the compiler will force the developer if the developer is creating some weird kind of combo over here. Right? So now he will come over here and create a goldfish over here, because this is the only type which this aquarium will accept. Okay. Now you can see there is no problem over here. Okay. So the getters are right now giving me more specific type. It's returning the more specific type. The compiler is giving error whenever we are creating some weird combo. Instead of giving us runtime exception, we force Java that the compile time error will occur if something weird will happen, because the compile time issue is better than the runtime issue, because the runtime will directly break in production if there is no proper testing has been done over there. Okay, so I think that things are a little clear right now. Why do we need generic? Right now, I will tell you one more thing. So here in this aquarium, as I said, I made this thing as T. Can I make it anything? Let's say I'm going to change this T to Q or S or V or something else. Let's say I'm going to rename this and I'm going to rename to something else. Is that fine? That is absolutely fine. You can write anything over here instead of T. Let's say I'm going to say ABC. Okay, if you're going to do that, that's also fine. You can write anything over here. Okay, and still this is a generic type. The compiler is not going to complain. If you're going to go to app.java, if you want to run the same code, this is still going to work fine. If you're going to run this, it's working fine. But if your architect or if your lead is reviewing your code, they will fire you, man, for sure. Because this is the normal Java convention. See, if you're going to write ABC over here, look at your variable name. Okay, this is also some kind of word. This is also some kind of word, right? So this doesn't look good. It is confusing. This looks like a variable name. Okay, so to make sure this will not look like a variable name, you need to format this. Okay, let's say I'm gonna rename this. So I'm gonna select this, right click source, refactor, rename, and I'm gonna say T, okay, T for type, and make sure this type can be only be accepted if it is a class or interface, okay? So my final question to you, this is what? This is a generic type, okay? So in your documentation, this is what? This is a generic type because it has a parameter. This is what? This is also a generic type, but looks like it accepts two parameter. K is a parameter, V is a parameter, okay? There are two types over here, okay? This is good, right? So a class definition, this is a generic type. Now, this is what? This is a parameterized type. So whenever you're instantiating the generic type, like this, right over here, whenever you're creating the object for that, this is parameterized type. But whenever you are writing something like this, you can still do that. Aquarium, I don't want to define the type. Aquarium is equal to new aquarium, okay? Something like this, okay? Let's say I'm not going to define the type, okay? Right over here, right over here. I don't want to define the type over here. For example, I'm going to put null. I'm going to put the object over here. Now this is what? This is a raw type, okay? Because I haven't defined the type over here. But this is a very bad thing, right? Because we are not defining the type for this aquarium over here. We're not defining the parameter for this generic type here. If you're going to hover on this, you can see aquarium is a raw type, okay? And the reference to generic type a T should be parameterized. The compiler is saying, hey man, I accept your code, but this doesn't look right because this aquarium is a generic type. So make sure you're going to be defining some type over here and make it parameterized type. If it is not parameterized type, then this is a raw type, and the raw type is bad. You don't have to do this because if you are not going to put anything over here, it will behave like this T will be an object. Now this will be an object, this will be an object, just like the first thing that you have written when we started this example, right? It will be exactly same as that. So if you're gonna go to app.java right now, if this will be object here, imagine if this is going to be object, if you're not defining anything over here, this will be object. If it is object, that means you can put anything over here because anything is the superclass of that, anything will be object, right? So you can put anything. You can put new goldfish, okay? And here you can put new starfish, right? That's fine. You can again create weird kind of combo. If you are you are taking a raw type, you are creating a raw type over here with two similar combo, then you are safe. You are almost safe over here because you are putting goldfish over here, you're putting goldfish over here. So you know what you are doing, right? So let's say you are doing aquarium.get fish2. Let's say the fish2 is goldfish or something, and you are doing goldfish over here because you know that the goldfish over here, that's something that you are putting, then you can happily assign it to goldfish, like goldfish over here, okay? And now you can actually invoke any kind of method like goldfish dot let's say swim. That's fine, right? Sorry, I have to make it aquarium 2. This is the instance. And if I'm going to run this should work fine, okay? But what about I'm going to change the type over here? I can put any kind of type over here because this accept object type, right? So I can put a shark here, right? But in that time, I'm going to have a problem because whenever I'm going to say get fish 2, this is not a goldfish anymore, right? So I cannot cast shark that I'll be getting over here to goldfish type. Now this is going to lead me to a class cast exception, right? Shark cannot be cast to the goldfish. You actually can put any kind of class object over here, like new integer of 10 or something. You can also put that. And see, you're going to be getting the same problem. You can put a string over here. You can put new string of Avilash or something. Okay. The compiler is not complaining. What you are saying is that get fish 2, you're going to be getting a string over here. Now that string, you are casting it to goldfish and storing it inside a goldfish reference, which is like stupid, right? And this is going to give you problem right now. So this raw types are bad. You don't have to instantiate your generic type object like this. You always need to specify the type over here. Once you specify the type over here, then the compiler will automatically gonna complain. Okay, and I'm gonna say goldfish. Now the compiler is going to complain that, okay, you cannot put the string over here. This need to be a goldfish object, right? Now, if that's the case, then why Java allows us to write code like this? Here, Java knows this is a problem. This is a problematic statement over here. The developer is putting some random thing over here, which should not be the combo that our aquarium should allow to create. But why Java is allowing us to create object of a generic type like aquarium, like this, like a raw type, okay? Why Java is allowing us to create raw type objects like this, okay? It should be like this, it should be like this, it should be like this, but it should not be like this. But why Java is allowing us to do this? That's a topic for another video. Hey, by the way, if you find it helpful, make sure you do subscribe to the channel. That is going to really help me. Do subscribe. If you like the video, make sure you're gonna hit the like button and just ask me anything in the comments. I'll be happy to help. Thank you and have a good day and practice all these things. I'll see you in the next video. Till then, happy coding.